Alright, this is your video for Accentuate the Negative Investigation 2.1, which is addition with rational numbers. Now, as always, the first thing we're going to look at is our learning target. So the learning target today is to use the addition algorithm to add positive and negative rational numbers together. And now we're going to do that using two different things. First, the algorithm, which is one of our vocab words, and the second is the commutative property when necessary. Now, I know we usually define vocab at the beginning, but I'm actually going to wait until we have finished these review sections, and then we'll go back up and define those together. So now let's look at review. The addition of same sign integers. Now immediately we see negative 7 minus 8, and the first thing we think of is, wait a second, we need to turn that into addition like we've been doing. So we always keep the first number the same with subtraction problems, and then we add our opposites. Now I've turned that into negative 7 plus and negative 8. And now that we have two negative numbers added together, our algorithm here is just to add like normal and keep the same sign. And this should be review from last week, but it's just a good reminder. But now what about part B, where we have the addition of integers with different signs? Now we need to use our absolute value algorithm. So let's first look at part A. Again, we see that we have a subtraction problem, and the first thing we're going to do is turn that into addition. Just good practice with that rule. So we keep the first number the same, which is 12. We're going to add our opposite, so 12 plus negative 40. Now, while some of you might be able to do that in your heads, that's great if you can. This is where our algorithm comes into play. So the first thing we always do is take our absolute value of both numbers. Of course, the absolute value of 12 is 12, and the absolute value of negative 40 is positive 40 because absolute value is always positive. And then we want to pay attention to which of those absolute values is bigger. Now we see that 40 is bigger than 12, and that actually tells us what the sign of our answer is going to be. Because 40 is bigger and was originally negative, our answer will be negative. And then to actually solve this, we subtract the smaller absolute value from the bigger to find our answer. In doing that, we see that we get 28, so our answer is negative 28. Now let's look at part B. Here we have negative 11 plus 4. So it's already an addition problem, which means we don't have to change subtraction over to addition. We can just start right away with taking our absolute values, which we get 11 and positive 4. Since 11 was the greater absolute value, again, we're going to keep that negative sign in our answer, subtracting the smaller from the bigger, and we get 7, which going back over here gives us a negative 7. Now, having done that, reviewing our algorithm, we can go back up to vocab and actually define the first vocab word. So the definition of algorithm is the steps needed to solve a given problem. So for part A, that was simply to add like normal and keep the sign that was with both integers. And for part B, it was to use absolute value to subtract and then solve and keep the sign of our greater absolute value. Of course, this is all with integers, so it was review, and we're going to, in just a few minutes, apply that to rational numbers. But now we have this other vocab word, commutative property, which we have not defined yet. So, the commutative property allows you to move numbers around when solving a problem. So our example here, we have 3 plus a negative 4 plus 3 plus negative 7. That would be a lot easier if we could clump together our positive numbers and our negative numbers, and the commutative property allows you to do just that. So then this problem becomes 3 plus 3 plus negative 7 plus negative 4. And then it's a lot easier for us to clump these together as 6, these as negative 11, and we are given our final answer, which we can then solve. And so that's what's nice about the commutative property. If you have a bunch of negative and positive numbers mixed up, you can just move them around and make solving them a whole lot easier. So now let's actually go down to the part of our assignment on commutative property. And let's look at our first example. So here we have negative 6 plus 12. Now some of you might be able to solve that in your heads using the algorithm that we used earlier, but it would be pretty nice if we could change that to 12 minus 6, which using the commutative property you actually can do. So we just switch around our numbers, 12 minus 6, and we can do that in our heads easily, and we just get 6, positive 6, because we know that 12 minus 6 gives us 6. Now let's look at our second example, B. So we have negative 4 plus 6 minus 3 plus 10. So before we do anything, let's go ahead and rewrite it as, negative 4 plus 6. Let's go ahead and change that subtraction to addition, so plus a negative 3 plus 10. And there's kind of this unspoken plus right here, plus the negative. So now this looks like our example with the definition. And we can move these around to make it easier to solve. So we can start with our two positive numbers, so 6 plus 10, and then we can fill in our negatives, plus a negative 4 plus negative 3. And there we can see that we get 6 plus 10 is 16, and negative 4 plus negative 3 is a negative 7. And then once we solve that, we see that our answer is 9. So again, moving those around just made solving our problem a little bit easier, being able to clump together those positive and negative numbers. So now let's look at adding and subtracting positive rational numbers. This is probably some more review for you before we launch into negatives, but it's helpful just to remember the process for both decimals and fractions. So first let's remind ourselves what kind of numbers are classified as rational. So going back to the classifying numbers web, like the first week of school, we know that rational numbers include natural numbers, which were our counting numbers, 1, 2, 3, going on to infinity. Our whole numbers, which are natural numbers plus 0, because remember 0 is not a natural number. Our integers, which then add in negative numbers, and then any number that can be expressed as a fraction. That also can be added decimals that go on forever with a pattern. Because we know irrational numbers, for example pi, that decimal goes on forever without a pattern. So, looking at our examples, the first one we have is 7.1 minus 3.45. So we can line those up and subtract like normal. Now the key part of subtracting decimals is that you make sure your decimals right here are lined up, because when we subtract, we just pull the decimal right down and leave it there. That way we don't accidentally move them one place, and then we can subtract like normal. So let's add our 0 in here. Then we have to borrow. 10 minus 5 gives us 5. Whoops. Then we have to borrow again. 10 minus 4 gives us 6. 6 minus 3 is 3. And our answer is 3.65. Alright, now the same thing would go if we had 7.1 plus 3.45. We would line them up again and make sure that our decimals are together right there, so we can carry it down to the bottom and just add like normal. Now let's turn to example B with fractions. So here we have 1/2 plus 3/4. Now whenever we're trying to add together two fractions, our first step is always to get a common denominator. So here we know that 2 and 4's least common denominator is 4, because 2 times 2 gives us 4. So we'll rewrite 1/2 with 4 as the denominator, and then since we multiplied this times 2, we gotta do the same thing to the top. And then we get 2/4, and we can keep 3/4 the same and add straight across, but remember, when we add together fractions, we don't actually add the denominator. It stays the exact same. So you just immediately think 4, 4, and 4. It's going to stay the same. And then we add 2 and 3, giving us 5. We're not quite done because that can be simplified. 4 out of 4 gives us 1, and then the remaining 1/4, which is equal to 5/4. So just a little bit of a review with adding and subtracting our rational numbers before we move on to the next section where we incorporate negative rational numbers. So go ahead and flip over your page and let's look at example number 1, which is -5 plus 7.34. Now here we can actually use our commutative property to make this into an easier subtraction problem. So we can move them around so that we get 7.34 minus 5. That's a whole lot easier to solve. So since we have a decimal, it's always safer to just line them up. 5.0, I add in that 0.0 so we remember our decimals, carry it down immediately, and then we can subtract. So let's add the other 0 here. 4 minus 0 gives us 4, 3 minus 0 gives us 3, and 7 minus 5 is 2. And we see that our answer is 2.34. All thanks to the commutative property, which made lining those up a lot easier. Now let's look at example number 2. Here we have two negative numbers. And we remember when we have two negatives from the front side of our note sheet, we can add like normal and then just keep that sign. So again, let's line them up. 4.0, add them together, carrying down that decimal, and then we add our negative sign because both of our rational numbers were negative. All right, let's move on to the third example. Negative 12.2 plus 3.4. So here's where we're going to bring back that absolute value algorithm from earlier with integers, because we see that negative 12.2 and 3.4, that doesn't give us an easy subtraction problem that we can just find using our commutative property. So the first thing we're going to do is pull the absolute value of both of these numbers, which gives us 12.2 and 3.4. Oops. And just looking at that, we see that 12.2 is bigger than 3.4, which means we're going to keep the sign from that 12.2, which was negative. Oops, that covers up the negative. And our answer is going to remain negative. So let's go ahead and write that immediately, just that negative sign. Now we are going to subtract that smaller absolute value from the greater one, lining up our decimals just like we did in the first two examples, immediately carrying that decimal down. We're going to go ahead and borrow. 12 minus 4 gives us 8. Borrow again. 11 minus 3 gives us 8. And we see that our answer is 8.8. But it's negative because of our sign, so we have negative 8.8. All right, and let's finish up with our last three examples. So let's look at these fractions. We have negative 1/5 plus 3/10. So the first thing we want to do is give those common denominators, which is going to be 10, because we know that 5 times 2 is 10. And if we had to multiply the 5 times 2, we're going to do that to the top. Oops. And that's going to give us 2/10. Go ahead and write that up there so we don't forget. Then we can just keep the 3/10 the same. But remember, this is a negative 2/10. Now here is where our commutative property can come in hand again, because we could actually rewrite this as 3/10 now minus 2/10, which gives us 1/10. All right, let's go down to our next problem. All right, in this next example, we have negative 2 1/3 plus a negative 6 with 2/9. Now, first instinct might be to just put that whole mixed fraction into one big fraction, which you could do. But an easier way might be to just turn that 1/3 into a fraction with a denominator of 9, and then you can actually just solve it as is. So let's do that first. Let's keep that negative 2 the same, but let's turn that fraction into one with a denominator of 9. Now, for 3 to become 9, you have to multiply it by 3. So we're going to do that to the top as well, and we get negative 2 3/9 plus negative 6 2/9. And now why I say we don't necessarily need to make two improper fractions is because here we see that at this point we're just adding two negative things together. So we can add like normal and keep the sign, and we can just first add the whole numbers. So let's immediately write that negative sign so we don't forget. But then we can add 2 and 6, which gives us 8, and then we can add those fractions, which gives us 5/9, because 3/9 plus 2/9 is 5/9. And because we have this negative sign in front of the 8, that negative then applies to the whole mixed fraction. And that's a lot easier than making our improper fractions. All right, let's look at our final example. Here we have -6 plus a -5 3/4 plus a +6. Now again, we can use our commutative property to change this up just a little bit. We can rewrite it as -6 plus 6 plus -5 3/4. And the reason we want to do that is because once we've put those 6's by each other, we see that they cancel out and give us 0. And then all we have left is 0 plus -5 3/4, and our answer is just -5 3/4. And that is why the commutative property is so helpful. Now, if this might have seemed like a lot to review rational numbers and the two operations, addition and subtraction with them, that's okay. On our website, we have a lot of resources available. There are videos that you can go to just remind yourself even further how to add together rational numbers, fractions and decimals, and subtract them, as well as how to add and subtract with more examples with negative rationals. So feel free to explore the website in Investigation 2. There's some practice and videos just to help your understanding go even further. All right, well, I hope the video helped and that you were able to fill out the notes. If it takes a while to get comfortable with this algorithm with rational numbers, that is okay. You'll have plenty of time to get enough practice in.